Assalamualaikum warahmatullahi wabarakatuh. Hello, I am Firmanila Kamil. On this occasion, I will explain the description according to the article that I have sent. This exposure contains research results with the title Preliminary Testing of Coarse Aggregate, Fine Aggregate, and Palm Kernel Shell Was Characteristics in Sustainable Construction. There are 5 reasons about my research. And the first reason is the importance of material inspection in concrete research. The materials are fine aggregate, coarse aggregate, binder, and water. The second reason is why just coarse aggregate and fine aggregates? Coarse aggregate and fine aggregate have a central role in determining the physical properties and mechanical properties of concrete. The third reason, so what aggregate? Selection of suitable aggregates is important. This is because the available natural resources are diminishing, thus obliging us to select suitable alternatives for the manufacture of concrete. How we can select it? This answer is waste utilization. Dedication to seek alternative material as aggregate filler for concrete should not create new problems. Potential aggregate substitutes should be washed. Waste presence would cause problems if not treated. This solution is a good fit. So, what material? This selection is based on the many industries around us. In Ketapang, there are many processing companies, mainly palm oil. So, I choose the kernel shell of palm oil. The purpose of this study is to conduct preliminary testing of the characteristic of coarse aggregate, fine aggregate, and palm kernel shell waste as construction materials. This research refers to several previous studies. The research from Smith et al. 2018 says about the importance of aggregate pretesting in supporting sustainable construction. Then, the research from Garcia et al. 2019 says about the relationship between the physical properties of the aggregate and the strength of the concrete produced. The research from Lee and Chang 2017 says about validity of retesting on the same aggregate with the same method. And research from Rahman et al. 2018 says about the extent to which the results of preliminary testing of aggregates comply with applicable standards and regulation. The research was conducted at the Soil Laboratory of Road and Bridge Construction Engineering Technology of Ketapang State Polytechnic. The research method used was observation. The data in this study are in the form of material test results. Tests carried out include measuring grain distribution, moisture content weight, specific gravity. The following methodology was followed in the research. First step is material collection. This is coarse aggregate, fine aggregate, and palm kernel shells. The coarse aggregate samples of coarse aggregate from natural sources were taken for comparison purposes. Samples of fine aggregates from natural sources were taken for comparison purposes. Palm kernel shell samples were obtained from the old palm plantation industry. The second step is sample processing. The coarse aggregate samples were washed and screened to remove contamination and fine particles. The fine aggregate samples are sieved according to the desired fraction size. The palm kernel shells were dried, cleaned of contaminants, and broken into appropriate size. And the final step is physical characterization. Aggregate testing was conducted using 3 samples of each material, except for the grain size test. The grain size of the aggregate was determined using sieve analysis as per ASTM standards. The specific gravity of the aggregate was measured using the water filling method. The porosity of the aggregate was calculated based on the difference in weight before and after immersion in water. The content weight of the aggregate in the solid and loose state was measured using a balance sheet. The test data were analyzed to compare the physical characteristic of coarse aggregate, fine aggregate, and palm kernel shell. Now, I will explain the research result about aggregate grain size, aggregate specific weight, moisture content and porosity, and aggregate content weight. This is table about aggregate grain size testing result. The grain size distribution of coarse aggregates shows that the majority of grain size are in the range of 13 mm to 19 mm. This is consistent with the characteristic of coarse aggregates in general. In the case of fine aggregates, the majority of grain size are in the range of 0.3 mm to 0.6 mm, which indicates that this aggregate have a finer texture than coarse aggregates. The grain size distribution of palm kernel shells shows that the majority of grain size are in the range of 2.36 mm to 13 mm, but with a higher proportion at 4.75 mm. This result is in accordance with the characteristics of palm kernel shells, which can be broken down into more varied size. This is table about aggregate specific weight testing data. The specific gravity of coarse aggregate falls within the range of 14 and 35 kg per meter cubic to 14 and 61 kg per meter cubic. Coarse aggregate has a lower specific gravity than fine aggregate and palm kernel shell. The specific gravity of fine aggregates is within the range of 13 and 62 kg per meter cubic to 13 and 89 kg per meter cubic. The specific gravity of fine aggregates tends to be higher than the of coarse aggregate, which can have an impact on the density and workability of concrete. The specific gravity of palm shells is in the range of 11 and 87 kg per meter cubic to 11 and 14 kg per meter cubic. The much lower specific gravity of palm kernel shells indicates a potential reduction in concrete weight when used as an aggregate material. This is table about moisture content test result. The coarse aggregate shows a low moisture content 0.61% to 1.56%. This indicates that the coarse aggregate has a good ability to hold water, which can contribute to the performance of the concrete mix. The moisture content of fine aggregate is slightly higher, 7.43% to 8.70% than the of coarse aggregate. Despite the higher moisture content, the fine aggregate still has a fairly good ability to hold water. The higher moisture content of palm kernel shells 16 and 88% to 17.76% indicates that these shells have greater water absorption. This is consistent with the porosity and texture properties of palm kernel shells. This is table about weight content test result. The solid content weight of coarse aggregate range from 13 and 21 to 13 and 45, while the loose content weight range from 11 and 65 to 11 and 90. The difference between the solid and loose weight content indicates the amount of pore space or vacuum in the aggregate. The solid content weight of fine aggregates range from 15 and 50 to 15 and 78, while the loose content weight range from 14 and 58 to 14 and 90. The higher loose weight content of fine aggregates indicates the percent of larger pore space than coarse aggregates. The solid contents weight of palm kernel shell range from 431 to 456, while the loose content weight range from 389 to 400. The significant difference between the solid and loose content weight of palm kernel shells indicates the open nature of the shape on structure. The conclusion of this research is the test result of grain size distribution, specific gravity, moisture content, and content weight of aggregate showed significant difference between coarse aggregate, fine aggregate, and palm kernel shell. In addition, difference of the moisture content of each type of aggregate can affect the property and performance of concrete mix. The solid and friable contents weight of each type of aggregate provides an understanding of the density and pore space of the aggregate. The potential utilization of palm kernel shells as aggregate materials in construction remains relevant, even though their size distribution differs from natural aggregates. The utilization of palm kernel shells as aggregate materials in sustainable construction has the potential to reduce structural loads and environmental impacts due to their lower specific gravity. Thank you.